As we have already discussed about the fundamentals of welding, and now we will discuss or we will learn about the welding processes. There are three type of main welding processes: fusion welding, solid state welding, and soldering and brazing. First, I will explain you what is fusion welding. Actually, fusion welding, it is the welding process that melt the base metals, for example, if you have two plates and these two plates are the base metals, and these plates are to be joined, heat is applied on this surface. Heat will apply on this surface, and due to heat these two surfaces will melt and form a weld pool, molten pool. Molten pool means both base metal will melt from here and here and form a molten pool. And after some time, it solidified and form a strong joint, and that joint will call weld. In fusion welding, sometimes filler material is added to the weld or sometimes not. It depends on the metal. If base metal has a low strength, then filler material is added to the base metal. Otherwise, you can do it without the filler material is added if base material has low strength. If base material has low strength, then filler material is added to the joint, otherwise not. The processes or the fusion welding process where filler material is not required, and uh, welding uh, welding is done without filler material, that welding or that welds called autogenous welding or autogenous welds. There are four types of fusion welding: arc welding, resistance welding, oxy fuel welding, and then a high energy beam welding. First, I will explain about the arc welding. Arc welding is a fusion welding process in which two metals or base metals are joined by the application of heat, and this heat will generate due to the electric arc. An electric arc is generated between the workpiece and the electrode. This electric arc generates a heat at a temperature of 505,000 degrees centigrade. It is the max temperature that electric arc will produce or can produce, and this temperature is hot enough or sufficient enough to melt any metal. Filler material is added during the operation. It depends on the strength of the base metal. If base metal has low strength, then filler material is added, because filler material increase the volume and strength of the weld. If filler material is added to the molten pool, and after adding filler material, when it solidified, the weld will form over the surface of the base metal, and that weld will call weld beat, right? And I will explain regarding the whole apparatus and whole setup of the arc welding. There is one DC source, electric source, a power source. It could be a direct current or an electric current. If it is a direct current, then polarity matters. Polarity means cathode and anode. Cathode negative and anode positive, because due to this negative positive charge, potential difference will create, and due to this potential difference, electric arc will produce. Because without this potential difference, no electric arc, or electric arc can't produce without this potential difference. And this force has two terminals. One terminal is connected to the electrode holder, which holds the electrode. Sometimes filler material is separately added, or sometimes this electrode acts as a filler material, or it is a source of filler material sometimes. uh, this is the table of the this is the welding table. The other terminal, this clamp, is connected to the table, and the workpiece is placed on the table. This is workpiece this is molten pool or molten metal, and this white thing is called shielding gas. Or sometimes when there is no shielding gas, this filler material or this electrode has a coating called flux, and this flux melts during the melting process or during the welding process. This flux creates the protective cloud around the molten pool, because this flux will prevent this molten pool from the nitrogen and oxygen gas to create oxides over the layer over the weld joint. Because if oxides or nitrites or the carbonates will form over the surface of the weld joint, and then it will create porosity corrosion problems over the weld. That's why flux is commonly coated over the electrode or filler material. When the source is on, sometimes there is two time of the polarity is created. Sometimes there is two types of polarity exist. One is straight and one is reverse. In straight polarity, positive terminal is connected to the workpiece and a negative terminal is connected to the electrode. In straight polarity, in reverse polarity, negative terminal is connected to the workpiece and positive terminal is connected to the electrode. It could be done in reverse or straight polarity. Straight polarity means this potential difference, and reverse polarity. Straight in straight polarity, electrode is in straight polarity, electrode is negative, means cathode, and the workpiece is positive. In reverse polarity, electrode is positive and workpiece is negative, right? When the electrode comes in contact with the workpiece, there is a gap between the electrode and the workpiece. There's a air gap. The arc will produce, and this arc will generate heat, and this heat melts the base metal. And after some time, when it solidify, it will form a strong joint or welt between two base metals. Of filler material is also added. As I have told you, it will increase the strength or the volume of the weld joint. This is the whole is the weld joint, means when two metals connect or fuse together, it will form a weld at this junction. When two base metal connected to each other, the whole assembly will called weldments. I have already explained this thing in the fundamental of welding. Now, electric arc welding. Electric arc welding has some essential terminologies like air arc shielding. As I've told you, arc shielding is required to protect the metal from the reactive oxygen, nitrogen, and hydrogen present in the environment. And electric arc and the weld pool is protected from the environment, because environment has moisture, and this moisture will create oxides over the surface, or oxygen will form oxides. Molten metal has a tendency to react with the moisture or oxygen, nitrogen. So to protect the molten metal and the electric arc, shielding gas is used in the electric arc welding. Electric arc, these shielding gas could are these shielding gases are inert gases. Inert gases are, for example, argon can be used, helium can be used, or the mixture of both can be used. Power source in electric welding, there's a formula. P is equals to IE. E is the potential difference and I is the current. If we multiply these two, current and the voltage, we can calculate the power of the electric arc produced in the electric arc welding. And one more thing is the power balance due to the heat loss during the process. As I've already explained you in fundamentals of welding, that all the heat transferred to the metal is not completely used to form the molten pool. Some of the heat is lost into the environment. So the heat gain and heat loss will be balanced by this equation. RHW is equals to F1, F2, I or NE. F1 is the heat transfer loss factor, and the F2 is the metal melting factor. There are some types of the electric this arc welding, shielding metal arc welding. In this process, more or less it is the same, but there's a slight difference. No gas will use to protect the this molten pool. This there is filler material, a consumable electrode is used. Consumable means during the process or during the sheet metal arc welding, this electrode will consume, means this electrode will melt and form a slag layer over the weld. This slag layer is the impurities layer. And after the welding, after solidification, you can remove this layer with the remove this layer with the help of chisel or hammer, or light hammering you can do to remove this slag. This electrode contains the and filler material, and this electrode, or you can say this is the consumable electrode, and this electrode will act as a filler material, and it is coated with the flux material. And flux material is cellulose, which is the mixture of the cotton and wood powder. During the welding, this material melts and form a fumes or the protective cloud, a gaseous cloud or fumes cloud over the surface of the molten pool to protect the molten pool from the environment. Um, this shield metal arc welding will also called the stick welding, and it is used in job shop, fabrication shop, repair shop, uh, ship welding. And one more thing here, reverse polarity will use, because reverse polarity produces stable arc. Reverse polarity will use a stable arc. That's that's why reverse polarity will use to create a electric arc. The whole process is same as the electric arc, like phenomenon is the same. Like when the electrode comes in contact with the workpiece, electric arc will generate, and that arc creates developed heat, and that heat will melt the base metal. And after a few seconds, this base metal will solidify and form a strong joint. And during the welding, filler material will also melt and deposit over the surface of the molten pool, or add it into the metal pool and form a slag. And after welding and after solidification, this slag will remove from the surface because of the impurities layer. Sometimes like it is not ideal case, this slag will react with the oxides and form a impurities layer, and this impurities can be removed with the help of hammer. The next type or second type of arc welding is the gas metal arc welding. Gas metal arc welding will also called metal inert gas welding, MIG welding, metal inert gas welding. In this type of welding, arc is maintained or arc is produced between the consumable bare metal wire or consumable bare electrode. Bare electrode means this electrode of filler material or filler wire is not coated with is not coated with is not coated with flux. So and when the and in this gas arc metal welding, torch or nozzle is used, welding torch is used. And this welding torch has one nozzle, uh, and in this nozzle there is some holes. As you can see, this is called gas diffuser hole. And what happened in this type of welding, when this torch or this electrode comes in contact with the workpiece, electric arc will generate due to reverse polarity. In this process, reverse polarity is also used. As I've already explained you, reverse polarity will produce a stable arc, like continuous arc. And when the electrode comes in contact with the workpiece, electric arc will produce. And due to this electric arc, heat produces, and this heat melts the base metal and form a molten pool. And both base metals will fuse together and form a strong joint called the weld. The only difference is that in this torch there is one passage, as you can see, This patch is for the shielding gas. Shielding gas, what is the function of the shielding gas? Shielding gas is here to protect this electric arc and this molten pool from the environment. As I've already explained you, we need to protect this molten pool for the formation of oxides. We need to protect it from the from the oxide formation, because oxide will form a corrosion over the surface of the weld. So shielding gas like argon and helium is used. And this bare wire electrode, if you I will go downward, and this bare wire electrode will continuously feed to the gun, this electric charge or gun, from the wire spool. Wire spool means uh, there is one pulley type wheel, and over this wheel a coil of wire is wound over this wire spool, and there is one button in the torch, and when you press this button, this wire is fed to the torch, is fed to the torch. When you press the button, this wire, this electrode wire is fed to the gun, because this wire is consumable wire. During the welding it is continuously melting, and this wire is continuously melting and adding into the weld, or adding into the molten pool. um this is the source of this is the gas cylinder, shielding gas cylinder. There's a regulator, you can regulate the gas flow rate. And this is the power supply. Normally DC power supply with reverse polarity is used, as I've explained you. And due to this polarity, potential difference will create, and this potential difference is necessary for the arc. MIG welding is normally used in factories, and it is used to it is used to weld pressure vessels, is used to weld some grills, normal handrails, grills. It is suitable for the ferrous and non-ferrous material. Ferrous means this iron parts, or non-ferrous metals means aluminum alloy, copper alloy. It can be used to weld copper, wire, aluminum alloys, zinc alloys, or it can be used to weld iron alloys as well. The third type of electric arc welding is the flux core arc welding. Flux core arc welding is same as the MIG welding. The setup is almost the same, but there is a slight difference. In this weld type of welding, continuous consumable tubular wire electrode is used. What does it mean? There is a tube like wire will use, and inside this wire there is a surface, or there is a flux coating is used, right? Inside the wire there is a flux coating, and this flux coating has the same function. It creates fumes which protect the molten pool during the welding from environment during the welding. In this process, there's one setup I will explain you. There's one wire spool, and this electrode wire, consumable electric wire, is wound over the surface of this wire spool. It's just like a bobbin used in the sewing machine. And this this whole pipe, this wire is fed into this torch. It has the same torch as in the MIG welding process. In MIG welding, there's one torch, and this flux core and MIG welding both have the same torch. And this torch, welding torch, there is one contacting tube, and the function of this contacting tube, it directs the electrode to the workpiece. And there is one button. When you press this button, this wire spool will rotate, and it wire is fed into the welding torch. Wire is fed into the welding torch because during the welding process, this electrode is consuming continuously, melting and depositing over the surface of the, or is adding into the molten pool, and this flux will form a slag over the surface of the molten metal. And as you know, slag is the layer of impurities, or because in this impurity layers there's different kind of oxides, carbonate present, and after the solidification you can remove this slag with the help of hammer or some kind of chisel. um, there are two types of flux core arc welding. One is the self shielded flux core arc welding, and in this type of flux core arc welding, self-treated only flux core will use, like there will be a tubular electrode, and in this inside this tubular there will be a flux core, a coating is used, and this coating will protect the molten pool from the environment, as I've already explained you. And there is no shielding gas will use. Self shielded core arc welding, there is no shielding gas will use. This flux core is enough to protect the molten pool. And inside this torch there is one passage for the shielding gas. Why shielding gas, or in which type of shielding gas is used? There is one more type, gas shielded flux core arc welding. In this type of for flux core arc welding, gas shielded core arc welding, there are two types of shielding will use. One is the flux core, other was the shielding gas. Shielding gas, argon, helium, and the mixture of both can use. In gas shielded flux core arc welding, melted pool is protected by two things: gas shielding and the flux core. Both are used to protect it. So there is a only slight difference in both between these two types of the flux core arc welding. And one more thing, in gas shield flux core arc welding, the deposition rate, like flux deposition rate, is very high, which makes the weld very strong. And um one more thing, in this type of welding, like in cell shielded flux core arc welding, straight polarity is used, and gas shielded flux core arc welding, reverse polarity will be used. And this welding process is best suitable to you weld stainless steel uh, with the mixture of argon and carbon dioxide gas. It is best suitable to weld stainless steel parts, like if you see in your house utensils is normally welded with the help of the spot welding or with the help of flux core arc welding. Submerged arc welding. Submerged arc welding is a continuous it is a continuous welding process, or continuous arc welding process. Submerged arc welding process. In this process, arc is produced between the continuously consumable bare wire electrode. Bare wire electrode means it is not coated with the flux. In this arc welding process, a blanket of flux is uh, used for providing the shielding for this electric arc. This electric arc is produced under the blanket of this flux. Uh, what is exactly the setup looks like? What exactly the setup looks like? There is one Hofer. From this Hofer, granular flux, like it is not in the powder form. It is some kind of small crystals, stones. And this flux is in the granular form, and it enters from this Hofer, and during the process it continuously fed or is continuously depositing over the surface of the base metal, over the surface of the base metal, and arc is produced under this flask. And the other side of the flask, there is one recovery part, and it works like a vacuum cleaner. It The lightweight flux, granular flux, will go back into the recovery hopper or recovery system. Um the one pump is installed in it, and this pump will suck all the lightweight granular flux from the surface of the weld. Only heavy flux or heavy granular stones or the crystals will be present over the surface of this over the surface of the metal pool. After some times, this metal pool will solidify, and you can remove all the flux over the surface of the weld. um, you can the application steel fabrications like I-beams, like if you see huge buildings have structural parts, and I-beams are used to construct the building. You can weld these two I-beams with the help of the submerged arc welding. Submerged means, as you can see from the word, what is submerged? Submerged means this arc is present under these flux, like it is submerged under the flux, and this is called the blanket of flux. This is the blanket of flux. And high heavyweight granular flux will form a slack, and as I've told you, after solidification you can remove this flux with the help of any solid hammer, and you can use this recovery recovery pump or recovery hofer. And in this part, reverse polarity is used to create current if you are using a DC source. For AC source, you don't need a positive or negative, because it a continuously current is a continuously fluctuating current, is AC current is fluctuating continuously. And this is the difference between, like, this is the differentiate or spatial part of the submerged arc welding. Like, this welding has two flux hover. One is for to fed the flux into the weld pool or the molten pool. The other part is to remove the flux from the surface, lightweight flux from the surface. We have already or we have discussed about the electric arc process or arc process, where all the electrodes are consumable. In all the process, electrodes are consumable. Now we have some types of electric arc welding or arc welding where non-consumable electrodes are used. Non-consumable electrode means it will not melt or consume or consume during the welding. Uh, Normally, non-consumable electrodes has high temperature or high melting points, high melting temperature. There's one type called gas tungsten arc welding. It's called tungsten inert gas arc welding. In this process, uh, non-consumable tungsten electrode will use the same gas torch or the welding torch is used in this process. Only difference is the we will use the tungsten electrode, and tungsten electrodes is hold into this gas nozzle. An electric current is passed through this electrode, tungsten electrode. When this tungsten electrode comes in contact with the workpiece, the electric arc will generate. That electric arc produces heat, and that heat is used to melt this base metal. This is the molten pool. To prevent this molten pool from the environment, argon or helium gas is used, and it will provide to this or it will provide to this molten pool from this torch. As you can see, there will be there's one torch, and this torch has separate path for the shielding gas, and between this path, between the nozzle, there is electrode fixed inside the nozzle, and this electrode will not consume during the gas tungsten electric arc welding. And moreover, one filler rod or one filler wire will add separately during the welding, And due to this arc, it this filler material will also melt. This filler material will also melt and added to the molten pool to provide the strength to this to the weld. Normally, aluminum, stainless steel, cast iron, wrought iron are welded by TIG welding, and this tungsten electrode has a high melting point. It will be around 3,500 degrees centigrade to 4,000 degrees centigrade. Uh, One special thing is that filler material is separately added to the weld pool, as I've explained in the previous processes. Normally, the electrodes act as a source of filler material, but in this process, filler material will add separately. So this is the whole thing, or how the gas tungsten arc welding works. And shielding gas is provided separately, and it will pass through the nozzle, and the same inert gas like argon, helium, or the mixture of both will use to protect the molten pool. Plasma arc welding, it is a type of the arc welding, and it is the non-consumable arc welding, electrode arc welding. In this type of welding, plasma gas is used to melt the base metal, or is used to weld the base metal. This plasma arc is produced in this process. First, there is one chamber. In this chamber, inert gas is transferred to this chamber, and under this chamber, there is one heating source. This heating source will provide heat to the inert gas. This inert gas will decompose into ions, positive ions, electrons, and excited atoms, and this inert gas will be converted into the plasma gas. Plasma gases consist of ions, electrons, and excited atoms. Plasma gas is at a temperature of 28 degrees centigrade, high temperature. That's why in this equipment of the plasma arc welding, water jacket is used to maintain the temperature of the welding. A DC power supply, direct current power supply, is used with the straight polarity. As you can see, the electrode is this is the electrode. This is the electrode. This is tungsten electrode will use this non-consumable electrode is used, which is tungsten, has high temperature around 3,500 degrees centigrade to 4,000 degrees centigrade. The temperature of this electrode, this high plasma arc will pass through this welding torch, and when this plasma arc will come in contact with this electrode, the non-transfer arc will generate between this nozzle and electrode. Between this electrode, non-transfer arc will generate. This plasma gas will continuously flow through this through welding torch, and at this point, at the orifice, a small orifice, this plasma gas has high velocity, and due to this non-transfer arc transfer arc, plasma gas will react with not non-transfer arc, and this non-transfer arc will convert into the transfer arc. Transfer arc has high power density. This transfer arc has high power density, and this transfer arc will use to melt the base metal. For example, for example, if you have these two plates, and you want to and they are come in contact, this is the contacting surface or faying surface. When these two metals come in plates 1 and 2 comes in contact, and you will direct the plasma gas over the surface of these two plates. This plasma gas, this fast moving high velocity or high energy plasma gas, react with the non transfer arc, and this transfer arc will convert into a transfer arc. And due to this transfer arc, the contacting surfaces will melt and fuse together and form a strong weld. No filler material is used. By the way, in this process, inert gas cylinder, the two function of inert gas cylinder, one end is going into the plasma chamber where plasma gas is produced. The other end, this dark blue end, is showing that this inert gas is also working as a shielding gas, because um, around in surrounding of this arc there is some air or oxygen or other hydrogen nitrogen gases is produced or already present. To prevent this arc from the oxygen nitrogen hydrogen, this inert gas argon or helium, a mixture of both, will use to protect them from the environment, or to and it is also used to protect the molten pool or the melting surface of the this base metal. And this type of welding is used to weld automobile subassemblies. It is also used in automobile transmission system, gear system, to weld the gears over the shafts. Metal cabinets like Hino Motors, they are using this technology to weld the doors into the cabins of truck. Window frames are also welded by this plasma arc welding. And home appliances, refrigerator capillary tubes are welded together with the help of plasma arc welding.